which is the additional practice that I gave you in class. And not that, because I just made a video, was this. So, James and Piper buried a treasure together. The field is 400 feet wide. So James drew a map. Right, here's the field. In real life, that's 400 feet. In his notebook, he made that into 8 inches. What is the scale that he used? Right, so very similar to the other practice. So the scale that he used was 8 inches, 400 feet. What are the 2 other possible scales that James could have used? Well, how can I rewrite this? Can you give me 2 other equivalent scales, equivalent ratios? Well, one of them could be the unit one. If you divide both by 8, you get 1 inch, 50 feet. Right. What if you didn't divide by 8 and you said, no, I don't want to divide by 8. I want to divide by, I'm going to change colors here, I want to divide by 4. Well, if you divide by 4, 8 divided by 4 is 2 inches. And 400 divided by 4 is 200. No. 8 divided by 4 is 2, and 400 divided by 4 is 100. So I just said the same thing in different ways. This is the original one, this is the unit one, and this one is another version of 8 over 8 inches over 400 feet. It's no different. Go back to the pizza. Here is half a pizza. This is 1/4 of a pizza. Sorry, 2/4 of a pizza. Got another pizza. This is 4/8 of a pizza. In all 3, right? They all 3 different representations of the same quantity, right? Whether you make half a pizza, 2/4 of a pizza, 4/8 of a pizza, you just ate the same amount. So this one, again, same thing. You just said 3 things, just wrote 3 scales, right? Equivalent to each other, 3 equivalent ratios. Piper, so this is James. Let me have Piper. Piper said, I want to draw this 400 feet, but the 400 feet, I'm going to use my scale of 1 inch to 20 feet. Right, so now compare these 2. Right, James used a scale 1 inch to 50 feet. Piper used 1 inch to 20 feet. So it's Piper drawing. When Piper draws the 400 feet and using this scale in her notebook, is it going to be greater than this or smaller than this? Remember what we said. Inside this 1 inch, there's 50 feet. Inside this 1 inch, there's 20 feet. So it's going to take more inches to represent 400 feet because there's less feet inside this inch. Right? So here, well, if you want to draw a proportion, right, you can say, well, if I have 400 feet using Piper's scale, how many inches would that be represented by? Cross multiply, you get 20x equals 400. Divide by 20, divide by 20. X equals 20. It would be 20 inches. Look how much bigger it would be. Right? Because you need more inches to represent. Right? Because 1 inch only represents 20. Here, 1 inch represents 50. So it's a huge difference between these 2. Okay, so I remember. On Piper's map, and again, let me write Piper's scales so I don't forget. On Piper's map, right, so hers, 1 inch is 20 feet. Right? So, what does 2 inches in her map represent? Well, so every inch represents 20, so if you have 2 inches, it would represent 40 feet. So this one's pretty easy. So you can set the proportion. You don't have to cross multiply here. You can just say, hey, how did I get to 1 to 2? Well, times 2. And therefore the bottom I multiply by 2 and I get 40. So on Piper's map, 20 inches is 40 feet. On Piper's, let me try again this question. So on Piper's map, the field is 16 square inches. I mean, you've got to understand what that is. This is a square inch, right? And 1 square inch means that this is 1 inch, right? And this is 1 inch. So if I asked you for the area of this square, it should look like a square. You would go, that's easy, Mr. Shaw. I'm going to multiply 1 times 1, and I get 1, and this would be a 1 square inch box. Yeah? And on Piper's map, there's 16 of these. So imagine 16 of them arranged line on line, whichever way. Right, so I'm just going to give you one possible representation. So 1, 2, 3, 4, 5, 6, 7, 8. There. There's 16 of these here. 16 of these square inches. 1, 2, 3, yeah, 16. That could have been one way. You could have had another one that looks like this. Oops, make it a little better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it could have been arranged this way. So there's how many of these? 16, again, 16 of these square inches in there. Everybody okay with that? That's, so on Piper's map, the field is 16 square inches, which means there's 16 of these. So you gotta understand that. Now, let me change that 1 inch to real life. So if I take that 1 inch, and in real life, what does that actually represent? So I can figure out the actual area. So we know that every inch in Piper's, so 1 inch represents 20 feet. So there's, let me take that box, which is this box over here, bring it to the side, and instead of 1 inch, I'm gonna change that 1 inch and write what? I can write 20 feet. Right? Because I'm replacing this 1 inch with 20 feet. And I'm going to replace the bottom one with 20 feet because that's the scale. Every 1 inch represents 20 feet. So now, if I ask you to find the area, and this is the actual area of this particular section here, right? A box is 20 feet and 20 feet. This would be 20 square feet. Okay, so this box right here, I'm going to shade it red or something, right? This or this in her notebook, it's actually how big? It's this big. In real, actual, right? It actually is. So each of these is 400 square feet. 400 square feet is 400 square feet, 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 and so forth and so forth. So we know that one of them is 400 square feet. So, but how many of these are there? There's 16. So we're going to take 400 of these, multiply that by 16, and you're going to get that. Oof, I don't know. I used to have a calculator. 400 times 16 equals 6,400 square feet. So the total area is 6,400 square feet. So is this 300 square feet correct? Absolutely not. It's incorrect. Hopefully I did a better job explaining it the second time. 5, again, that comparison. Ugh. So let's write our given scale. 4 centimeters is 20 meters. In your notebook, 4 centimeters represents 20 meters in the middle. That's what you get. An understanding, I'm about 1.8 meters. So if you round me to 2 meters, right, you would need 10 of them. So 4 centimeters in your notebook, 4 centimeters about this distance right here. That 4 centimeters in real life represents 10 of them, one on top of each other. But let's simplify this and write it in terms of 1 centimeter. So 4, divide that by 4, divide this by 4, and we get 5 meters. So this is what I'm going to compare all these A, B, C, D to 1 centimeter over 5 meters, because I'm going to simplify each of them. All right, first of all, 4 inches to 20 inches. I'm not even going to do this one because the scales are, what do you call it? It's in inches. Okay, no, I'm not even going to lock it. I don't even believe why, I don't even know why they put it there. 1 centimeter to 5 meters. Well, let's write that as a fraction of this. 1 centimeter to 5 meters. Oh, we have a winner right off the bat. So is this the same as this? Yes, it is. So B is good. C, 10 meters to 2 centimeters. Are you kidding me? So 10 meters to 2 centimeters. Let's simplify this. So 5 divided by, you can divide by 2. I'm going to divide by that by 2 because I want the centimeters in terms of 1. And 10. So we have another one. 5 millimeters to 3 meters. Oh, 5 2 L's, millimeters to 3 meters. Got the same thing as 1 centimeter. So 5 millimeters. Ugh. Remember, there's 10 millimeters in 1. So you have to know that 10 millimeters is 1 centimeter. So if I have 5 millimeters, how many centimeters would that be? You can cross multiply. 10 times x is 10x. 1 times 5 is 5. Divide by 10. Divide by 10. X equals 0.5. So we can rewrite this in centimeters because the comparison here is between centimeters and meters. And this is millimeters and meters. So I'm going to change this. For 5 millimeters, I'm going to write 0.5 centimeters. And the bottom is 3 meters. Now, I still don't know if this, right, is the same as that. Well, let's change it so that the top is 1. So if let me rewrite this, 0.5 centimeters represents 3 meters in real life. I'm going to change that to 1 centimeter. So how do I get 0.5 to become 1? I can divide that by 0.5, which means I'm going to divide the bottom by 0.5. What's 3 meters divided by 0.5? And that's going to give you 6 meters. So is this the same as 1 centimeter and over 5 meters? No, it's not. So this one also, this doesn't work. Inches to feet, I'm not even going to look at. So the only two that worked was B and C. Okay. What a waste. Six, we have a blueprint. The living room is 4.2 inches wide. So somebody drew the living room. And it's 4.2 inches wide in the drawing. The blueprint has a scale of 1 inch. In this blueprint, 1 inch is 5 feet. Okay. How wide would the living room be on another blueprint that has a scale of 1 inch to 20 feet? Well, so let's take care of this blueprint first. So this blueprint, 1 inch is 4.2 inches is the living room. Every inch represents 5 feet. So let's find out what it actually represents in real life. So 4.2 inches, we can set up a proportion. I don't know how many feet 4.2 inches, so I want to find out. So cross multiply, we get x. 5 times 4.2. That gives us 21. So in real life, the living room is 21 feet. Okay? That's just using this scale. So somebody else looked at your living room and said, well, the living room is 21 feet. Right? So in real life, the living room is 21 feet. We want to know what the representation of it would be in that person's notebook. So let's use their scale. Their scale is this. So they're using a scale that says 1 inch is 20 feet. Okay, so inches on the top, feet at the bottom. So notice the difference in scale. So let me just look at this, his scale, and look at our scale. 1 inch is 5 feet. His one is 1 inch, 20 feet. So inside his inches, there's 20 feet. So there's more in there, right? Whereas ours, every inch that we have is 5 feet. So it's going to take less in his drawing to represent our neighborhood, our living room. So our living room is 21 feet. How many inches would that be? Well, cross multiply, we get 20x. 21 divided by 20 divided by 20. X equals, and what's 21 divided by 20? 1. 21 divided by 20 equals 1.05. So in his drawing, of the same living room, he would represent it as 1.05 inches, right? Because in his scale, every inch represented a bigger distance than the original one, which was 1 inch at 5 feet. Okay. And that's that.